Hey everyone, today is day 10, Math 133, and we are going to be talking about the Chapter 4, Project 2, and we're also going to start the sample midterm, and we're also going to talk about the midterm. Uh, all right, uh, let's start off with talking about the midterm, I think. Um, so I just sent you an email. Um, for with instructions on the midterm. It's a PDF. So it's this one. Um, Send it to your Jackson College email. If you didn't get it yet, let me know. But yeah, I can try to drop it in Remind maybe. Um, okay, so the midterm is going to cover chapters 1 through 6, and there's two ways that you can take the midterm. The first way is you can take it at the testing center. You can take it at the testing center on February 24th, 25th, 26th, or 27th. I'm pointing that one out first because I think that's the better option. Okay. But the other option is you can take it with me in Zoom. Okay. If you take it at the testing center, they have walk-in hours. I believe they're open 10 to 6, and there's no time limit. So if you show up at 10 a.m., you can work the entire day. If you get there at 1, you can go until they close at 6, so that's 5 hours. It's plenty of time, more than enough time. Okay. But if you are worried about running out of time, if you've run out of time on tests before, if you have any anxiety around that, definitely take it at the testing center. You don't have to worry about the time. Now, I will point out that if you're going to take it on February 27th, that is Friday, their hours are different on Friday. Let's see. Yeah, let me see if this link will take me there. Their hours on Friday, I believe, are 10 to 2. So you have 4 hours to take it, which is still more than if you do it with Zoom. Okay. Um, let's see. Yeah, so 9 to 6. Okay, so they're open 9 to 6. Friday on the 27th, February 27th, they're open 10 to 2. Um, and you don't have to get an appointment. I do recommend that if you are going to take it on Friday, February 27th, I would recommend getting an appointment because what you don't want to have happen is you show up on that Friday right before spring break and they're very busy and so you can't get a seat right away. Okay, so I don't want that to happen to you. So if you're taking it on Friday the 27th, uh, you probably want to get a an appointment. Okay. Otherwise, it's just walk in, right? You could walk in on the 25th at whenever and say, I'm here for Math 133, take an exam. So you can bring your computer with you. They do have computers there. If you bring your computer with you, I still recommend that you have your Pearson username and password written down. You're allowed to have an 8.5 by 11 piece of paper with you, front and back. You can have whatever you want written on it. I would recommend having your username and password on there just because, you walk into the testing center, you actually accidentally drop your computer and it breaks, and now you can't log into StatCrunch, and you need StatCrunch for the midterm, right? So, um, the okay, so that's the testing center. You're also allowed to have your exam notes packet, which starts on page 253. Yours is yellow, right? You're allowed to have that with you. Mine's just white, and you're allowed to bring blank paper. So they're going to give you a paper test. So they're going to hand you the test. You're going to write out your answers. They're going to collect that at the end, and they're going to give it to me. Okay. So I would bring a pencil. We always do math in pencil. We don't use pen. And you're allowed to bring blank paper. If they say something like, "Oh, you can't have the blank paper," they'll have blank paper there for you. Okay. I don't want you to have to use your exam note packet for scratch work. Okay. Um, you're allowed to be on StatCrunch and Desmos, Google Spreadsheet. Those are the sites that you're allowed to be on. Okay. Okay, so that's at the testing center. Now, the other option is you can take the exam with me on Zoom. If you're going to do it on Zoom, we will be doing it on Thursday, February 26th. We'll do it in the morning and the evening. Okay. So to give you a little bit more time, we're going to start a little earlier, end a little later. So 9 to noon on the morning of the 26th, or from 6 till 9 in the evening. Okay. So you guys are on the evening right now. And we started at 6:30. Okay. So we'll start a little earlier. We'll start at 6 and we'll go until 9. Okay. I can't go past that. So, like I said, if you're worried about running out of time, then take it at the testing center. Usually people are able to finish their exam in like 2 hours. But if you're looking at this and you're like, oh man, I don't get this material. I'm worried. Like, I don't want you to have test anxiety, right? So you don't need to worry about that. Okay. So yeah, testing center might be better then. Usually, so I do usually have like one or two people that run out of time. Okay, so if you are taking it with me, let's see. Okay. So the sample midterm is different from the midterm. The sample midterm is a worksheet. It's basically a study review guide. Okay. It is worth points. We're going to be working on it together. We're going to start working on it today, and it starts on page 424. Okay. Don't get the whole thing out right now. I mean, don't, you know, you can if you want, but page 424, we're going to cover the first two pages today. It's 14 pages long, which is pretty long. That's not how long the midterm is. The midterm is going to be 9 pages, which is still long, but not as long as the sample midterm. So sample midterm is on page 424, and we're not going to do it all today because, like I said, it's 14 pages. We're not going to wait until it's due. So in Canvas, it says that, let's see, if I scroll down here, and if you click on day 13, it says the sample midterm is due February 26th. So it's day 13, which is where you'll click on the sample midterm and submit it. Okay. Just like our other worksheets, just like the Chapter 6 review worksheet. It's worth 200 points, so make sure you do it. But if we waited until that day to do it, like there's no way we're going to do 14 pages in a day, right? We're going to do a little bit today, a little bit next week on Tuesday and Thursday. Any stuff that I don't cover, Cindy and Elaine, they're going to cover it in their class. So we're going to cover the whole thing, okay, the sample midterm. But okay. So the midterm, though, if you're taking it with me on Zoom, we're doing it on the 26th. And when you're done with it, you'll come in here to Canvas and you'll click right here, the midterm, and you're going to submit it just like a normal worksheet. Okay. So, you know, uh, it's going to be, I'll email you the link to the exam, and then you can either print it, or if you don't want to print it, you can have it up on your screen and you can write your answers on a blank piece of paper, and then you will upload that just like you've been uploading your worksheets with your cam scanner on your phone. Okay. Says it's due within 5 minutes of finishing the proctoring exam. So if you're taking it with me from 6 to 9, it's due at 9:05. Okay. If you're like, oh my God, 5 minutes, that's not enough time to upload a scan, then maybe, we might want to end a little early. That's fine. Um, so uh, what I can't have happen is, you're in the exam at 9 o'clock. I say, okay, time's up, stop working on the test. And then you turn it in at 11 o'clock. I had someone do that. And I don't know if that person kept working on the exam or if they went and looked up answers on Google or AI or whatever. So, I don't want to have a situation like that where you turned it in late. Okay. So if it's turned in past the deadline, which is 9:05, I'm going to take 1 point off for each minute that it is late. Okay. So that's only if you're doing it with me on Zoom. If you are doing it at the testing center, they will hand you a paper test and you'll write your answers on that paper test, and you do not need to submit anything to Canvas. Okay. Okay, so let me jump back over here. I'm jumping around a little bit. I apologize. Chapters 1 through 6. Okay. Um, So if you're taking it with me on Zoom, uh, I need you to be on camera. I need to be able to see you and your workspace and your screens. Okay. So here's a good picture where I can see her screen. I can see her workspace. I can see that she doesn't have her phone in her hand. I can see that she's not on a website on ChatGPT looking up answers, right? I can see that she's either on StatCrunch or Google Sheets. So I need to be able to see your screen. I need to be able to see you and your workspace. Okay. So I'll stop my screen share for a second. So if you have a webcam, all you're doing is you're setting it over here. So now look, I can see the screen, I can see workspace, right? So that's good. Now, I don't want you to have to hold your webcam up all for 3 hours, right? So if you can't put it there, sometimes what people will do is they will log in on their phone and they'll have their phone pointed at their workspace and then they'll also log in on the computer, and so that way I can see them, okay, and see their screen, okay. So if you want to log in twice, that's fine, that works, okay. All right, so let me pull this back up. There we go. Um, okay, so here's another good one. So I don't need to see your face. I just need to be able to see that you're not on a you're not looking things up where you're not supposed to be. Okay. Um, right. So once I can see your workspace and your screen, that's when I will send you the link to the test. Okay. So if you show up at the test at 6 p.m. and you don't have your website, you don't have your camera set up, you're gonna have to take that time to set it up. So, maybe you don't get the test sent to you until like 5 minutes in. So make sure you get that set up. Okay. So you know, I know, so we're going to start the exam at 6 o'clock. Um, try to log in early. So, like, I'm telling you now, February 26th on Zoom, okay? Get, whatever you need to do. Make sure that you have, childcare, make sure you have, have distractions, make sure that, work is aware. So, like, you're not like, all right, well, I get done at work at 5:30 and then I drive home and take the test at 6. That's kind of cutting it close. What happens if, you break down or there's a traffic or whatever, okay? So there are emergencies, and if you do end up having an emergency, we need to document that emergency. If you have a doctor's note or whatever, like, things happen. We understand. So, um, all right. There's that, all of this. This is the location of the testing center. So, um, okay. All right. I think that's it for that. So do read through that though. Okay. Um, I think that's all I had to say on the midterm. What did I miss, Cindy? Feels like I'm missing something from the midterm. Midterm is 30% of your grade. So can you bomb the midterm and still pass the class? Yes, you can. So mathematically speaking, okay, if it's 30% and you get zero on the midterm, then the best you can get is a 70% if you get a perfect score on everything. So 70% is passing, but then you're not gonna have a perfect score on everything. So if you get a zero, okay, that's a problem. But can you get like a 50% on the midterm and still pass? Oh, yeah, absolutely. You get a 50% on the midterm. The best you can get is an 85 in the class, and that's still passing. That's not a problem. Okay. So if you do take the midterm and your score is low and you're worried about that, we can talk about like whether dropping the class is an option or not. Um, when I was a freshman, my first semester, I withdrew from a class. I dropped a class because I took on too much, and this class was just, way too much. It was way too difficult, and so I ended up with a W on my transcript for withdrawing. And a lot of people say W stands for wisdom. It didn't affect my GPA. Okay, so that was better than just failing the class outright. Okay. But you're not going to fail. You're going to do good because we're going to work on the sample midterm. We're going to study, and we're going to be all right. Okay. All right. We'll talk more about the midterm as we go. If there's questions on anything, let's jump into the chapter 4, project 2. So in Canvas, if you click on the chapter 4, project 2, it'll bring you here. And there's two links, and I'll drop those both in the chat. This first link is going to uh, bring you to the document where we're going to fill in our answers. So there's that. The other one is the link to the spring 2026 forearm length and height data that we collected in the survey that you guys filled out. I've already gone and graded that. So anyone who filled out the survey, you should see that you got 10 points on that. All right, so there's that information. So make sure you sign in or register. Yep, sign in. All right, so let me jump back over though to this. Okay, this is what I want to do. All right, so this is where we're going to enter our answers in the Google document. So we're going to go File, make a copy, right? And it is not fall, it is spring 26. I mean, that's fine. You don't have to rename it, but save it. Where do I want to save it? So I want to save it somewhere that I'll remember so that I can study off of it. So you can put it in my drive. That's fine. Name. All right, access the data in StatCrunch. This activity uses forearm length and height data collected from your class to determine a linear model. Your instructors made the data set available to you in StatCrunch. That's here, right? And it's not anonymous, so I do have everyone's name in there. So I apologize now. Everyone knows how long your forearm is. Sorry about that. So some personal identified information in there. All right, so create a scatter diagram of the paired data using arm length as the explanatory variable. Okay, paste the result here. All right. Oh, wait, we wanted to do stat crunch path is graph and then scatter plot. Okay, graph, scatter plot. So we're going to come over here. We're going to click on graph, scatter plot, and we'll select our X variable. So I just copied this from the survey. So it's got the whole freaking question in here. What is the length of your inner forearm to the nearest centimeter? Blah, 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 blah. So it's just this one, forearm. And then our Y variable is height. And then we will hit compute. Okay. So there is our scatter plot. Now, I want to point some things out. So first of all, I've got this one dot way up here. If I was going to draw a line through the middle of this data, I'd probably draw it through down here, but this dot way up here, that's an outlier. Yes, someone is way off of the line, okay? Way outside the scope of the normal data, okay? Anytime you're dealing with real data, and this is real data, right? You guys filled this out. So this is your actual height and stuff. So anytime that that you are looking at real world data, there's always outliers that you have to deal with, okay? Yeah, I went to graph and then scatter plot. Graph, scatter plot, and then I selected my X and my Y, and then I hit compute, okay? So, you know, when you're working as a statistician, like you have to be able to handle those outliers. We've talked already that linear regression is not resistant to outliers. Having this outlier on your data is going to mess things up. When I actually graph or when I actually do the linear regression, right? If I do the linear regression, and you guys don't need to do this yet. I want to point out something before we jump into it, okay? I'm going to get a terrible correlation coefficient, negative 0.06, and it's negative, right? So that actually means my line is going down, which means that uh, people with that are short have long arms and people that are tall have short arms. And we know that that's probably not true, right? It's because this point right here is pulling this side of the line up toward it. And so we're ending up with a line that doesn't make any sense. It's not useful. Okay. So this happens every semester. We put out this that we end up with an outlier or something weird happens, and this happens with any data that you're dealing with. So it would be nice if I could say that like most of my job as a statistician is just, making the charts and then presenting them. But that's not true. Uh, at least a third of my time is spent cleaning up the data. Even though I'm not the one that collected the data, I need to make sure that the data is right. Okay. So I don't think that this is actually right. This person has a height of 257 centimeters. What is that as in inches? 257 divided by 2.54. That's how many inches they are divided by 12. This person is 8 feet tall. Okay. I mean, that's possible, I guess. So, uh, but I think that's probably a mistake. So, um, all right, so where is that in here? So that's this one right here. And I'm not calling anyone out. If you filled this information out, so it looks like it was Kelly, and that's totally fine. Don't worry about it, Kelly. Like I said, this kind of thing happens all the time. Okay. Um, so probably what I would do is I would go to Kelly and I'd say, okay, is this number accurate? What's happening here? Probably what happened is she meant to type 157. 157 is a normal height in centimeters. So like it looks like the next person, Raya, she's 154. So 157 is probably what she meant, okay? Now, that could be an option, is it was a typo. Another thing that could happen is, no, this is actually accurate. And if this is actually accurate, then I need to use this and include it because 8 feet tall, that's not the maximum height that a person's ever been. Okay. Another thing that could happen is maybe I can't get a hold of Kelly and I need to just completely delete this row. I need to just throw it out. Okay. Okay. So what I'm going to do though is I'm going to change it to 157. Okay. And Kelly, like I said, I'm not calling you out at all. This happens all the time. This happens with, I'm working in a company that, makes billions of dollars a year and their data is not accurate. It's like, okay, maybe it's like 95% accurate, but I need to deal with those weird outliers and things. So, um, I need to be aware of that because that's not the only issue, right? If I look through here, there's other issues. Like right here, it looks like we have two Brittany Henrys and they're the same height. So it looks like Brittany entered her name twice. So probably what I need to do is I need to delete this row. If I right click on it, I can delete this row. Um, Now, all this stuff that I'm doing, cleaning it up, is stuff that you are not required to do. If you would like to use this scatter plot, you are totally welcome to. I'm not going to because it's going to throw off my results. There's one other issue I want to point out. Looks like Chanel is also listed twice, but hers is 156. And then down here, she changed heights. So only one of those is actually accurate. So I'm going to delete this row as well. I'm going to right click on it and click delete selected rows. Now, you do not need to do that, okay? You do not need to delete the rows or change this one. Where was she? You don't have to change Kelly's, but I'm going to do that because it's going to make my prediction a little more accurate. So now if I do uh, graph scatter plot, it's like my x-axis is my forearm, y-axis is the height, and now if I hit compute, this data is a little bit better. Is this data perfect? No, it's still not perfect. Okay. You'll notice that I have some weird things happening with the way that people were measuring. This one, it looks like this person measured their height as 20, or sorry, their forearm, 23 centimeters, 27 centimeters. Those are measured to the nearest centimeter. But then down here, this person measured and got 30.48. Do I think that this person is actually looking at their forearm and measuring, oh, it's 30.48, like 30 centimeters and 4 millimeters, 4.8 millimeters? No, they're probably not, right? Probably what happened is they measured in inches and got it to the nearest inch and then converted it to this. So we're not even measuring the same way, okay? So, like I said, there's always weird things when you're looking at real data, and you have to be able to handle that. Like when we're dealing with data in the class, and I give you like the Google spreadsheet on like the pet dogs and stuff, like that data is very clean, okay? So just something to be aware of. Um, so well, yours, all of these are fine, by the way. I'm not worried about whether these numbers are right or wrong. So it doesn't, again, I'm not calling anyone out. So, like, if you wrote 20.32, even though you were supposed to round it to the nearest centimeter, um, I'm not, you still got full credit for doing for submitting your survey. Okay. So no one's losing points for entering their information incorrectly. And I'm actually glad that Kelly gave us an outlier because it gave me a chance to talk about how to handle them. Okay. Okay, but let's go back and let's start filling in our answers. So, what are we doing first? We're doing a scatter diagram and then we're going to paste it here. Now, my scatter diagram looks like this. Yours might look different if you didn't get rid of that outlier or if you didn't change that outlier. You could have just deleted Kelly's row. That's also fine. I'm going to just use this one. And part of these projects is getting you an opportunity to work on your own data. So you do not need to do that data cleaning that I just did. Okay. You can just have it include an outlier. I'm okay with that. All right. So now that I've got this, I'm going to copy it over in here and we're going to paste it here and there is our scatter plot, or at least this one's mine. Okay, so um, judging from the scatter diagram, what type of linear relationship appears to exist between the data? Strong positive, strong negative, no relationship. Okay, so my dots are definitely not in a straight line, so I don't think it's I don't think it's a strong relationship. But I don't have any dots in the upper left here anymore. I do have one dot down here. This one might also be an outlier. This person is 155 centimeters tall, but their forearm is very large, 30 centimeters. So, um, yeah, and again, I'm not calling anyone out. Like my, I'm not a tall guy, but I have long arms. Uh, I have monkey arms. When I was getting fitted for my tuxedo for my wedding, like they had tuxedos that fit like my body, but like nothing covered my arms. They're too long. So my wife always makes fun of me, but it's okay. She's got T-Rex arms. So um okay. So someone said moderate positive. Okay, I can go with that. Um I definitely think that it's positive. If I had to draw a line through here, I think like see these dots right here in the middle. I think this is where my line's going to be. Um, so I think it's positive, and that should make sense because taller people usually have longer arms. Shorter people usually have shorter arms. Okay. Um, all right. I'd be okay with moderate or weak. Um, so what's give me some more votes. I got one vote for moderate positive. What do you guys think? Looking at my dots here. Now your dots might be different from mine. Like I said, you might have cleaned up the data. You might have actually thrown out this outlier as well. So Kelly says moderate positive. Okay, we'll go with moderate positive. Okay. Moderate positive. Explain why you think this is because my dots generally are trending upward. Okay. Right. We kind of headed upward. This, yeah. Um, all right, let's see. So question 3. Using StatCrunch, conduct a simple linear regression on our data set. We do stat, regression, simple linear. And there's two parts here. I want the output with all of the numbers and stuff, and then also the graph with the dots and the line. Okay. So we're going to come over here to StatCrunch, and we're going to do stat, regression, simple linear. And our x-axis is this one. Our response variable is height, and we'll hit compute. And here's our results. So I'm going to grab a screenshot of this. Now, you don't have to do a screenshot if you actually, if you just click in the upper left, and hold your left mouse button down and drag it down. I believe you can copy it like that. And then when you paste it in here, it'll look fine. Yeah, so you can do a screenshot or you can paste it in like that. That's fine either way. All right, I also need the graph. So in StatCrunch, there's a button in the lower right-hand corner. If you click on that, it'll come over here to your dots and your line. I'll get a screenshot of that. I'll paste that here. Okay. All right, state the value of the linear correlation coefficient for these data. Okay, so correlation coefficient was, if you click the left arrow in the lower right-hand corner to go back to your numbers, my correlation coefficient is 0.244. Oh my God, that's a terrible correlation. 244. Oh my goodness. And that's even after cleaning up that outlier. So probably want to clean up this one and this one as well. So, all right. So there's my correlation coefficient. And yours might be different, okay? So put in the number that you have, don't just copy mine. And so, up here, you copied your results. So put in what you have. And if you didn't do any of the cleanup, I think it was like negative 0.06 or something like that, right? So uh, yeah, I'm not going to mark you off for that. Yeah, so Nathan, yep, negative 0.061. Um, so that's fine. Okay, it's not a good correlation, but yeah. So does the value support or contradict the strength and direction? So uh, it does not. Where does 0.24 land? So on my number line, 0.24 is no linear relationship. Oh my God. He said it was moderate positive. Um, all right, so uh, contradicts it the strength because it is no linear relationship, right? The correlation, yeah. So correlation is no linear relationship. All right, interesting. State the value of the coefficient of determination for these data. Mine was R squared was 0.059, but I got to round that 9 up because of the 7, so 0.060. That's my R squared. Interpret the value from number 6 using the context of the situation. So that is at the bottom of page 255. We say R squared, and we write it as a percent of the total variation and then we write out what Y is, explained by the least squares regression line. So Mine was 0.06. So, um, as a percent, that is 6.0% of the total variation in, uh, so the Y value is, I, so the like I said, I left the name of the whole question in here. What is the height to the nearest centimeter? I'm not gonna write the whole thing out. It's just height, right? Should be just height. For me, 6% of the total variation in height is explained by the least squares regression line. State the equation of the least squares regression line. Paste your result from StatCrunch. Um, so somewhere in here is the equation, but since I didn't change my labels, it's a crazy hot mess. So I'm going to redo this and I'm going to change my labels. So this is forearm length and this is height. Okay. So now when I do stat regression simple linear, it's not that whole long thing. It's just forearm length versus height. Because now when I do compute, I can actually see the equation. It's right here. This is my equation. Height equals 143 plus 0.9 4 times the forearm length. Okay. So I can copy that into here. You could also, you don't have to copy it. You can just write y equals and then put in your number plus your slope times x. Okay, so you can put y and x here. You don't have to put height and forearm length. But what I had a second ago was impossible to read. It was this, right? So it's right here, y equals 143 plus 0.9 times x. But yeah, my labels are terrible, right? So again, part of cleaning up your data is making it easy to read. So I should have changed those labels, okay? All right. And your numbers will be different. Okay. So if you didn't do the same data cleanup that I did, don't just copy this. Um, so you want to make sure that you're putting in the numbers that you got. Okay. Uh, State the value of the slope. So mine is 0.911. And if you watch the video from this morning, I even have a different number from there. Okay. So we're all going to have a different number, and that's okay. It's part of working with the projects. Interpret the value of the slope of the regression line. That is on page 255 in the middle, and it goes if forearm length increases by 1 unit. The unit for everything we were supposed to be using centimeters. Oh yeah, I could slow down a little bit. I apologize. So, if forearm length increases by 1 centimeter, height is expected to increase by approximately, and then you write out what your slope is. 1 centimeters. Now mine has a positive slope. If yours has a negative slope, you'll say decrease, and then you'll put the slope here, but without the negative sign. Okay. Um, if you're having a hard time finding your equation and you don't want to change the labels, you can see the y-intercept and the slope right here. So you can just type out y equals and then slope is 0.911, 0.911 x plus, and then your y-intercept, 143.479. Okay. So you can do it that way instead, because like I said, if you're having a hard time finding the equation in the mess, you can just use these, the intercept and the slope. State the y-intercept. Y-intercept is 0, comma, mine is 143.479. Okay. Explain why the y-intercept does not make sense in the context of the situation. So we'll say impossible for. Now, usually the impossible part is the 0 for x. Can someone be 143 centimeters tall? Yeah, they can. That's pretty short, but they're certainly not the shortest that people have ever been. In this case, the issue is the 0. It's impossible for. So if x is 0, what does that mean? What would happen if x was 0? Yeah, so it's impossible for a person to have uh, a 0 centimeter forearm. Okay. So I guess it's not technically impossible. I mean, I guess you could have your hands attached to your elbows, some kind of weird dwarfism, but yeah, that's not going to happen. So, all right, what value did you give as your forearm length? So everyone's gonna have a different number there. If you don't remember what it was, that's why I left everyone's name in here. Again, it wasn't to call everyone out. It was so you wouldn't have to go and remeasure yourself. So I didn't include myself, so I'll say that I'm 27. That's a reasonable number, right? Yeah. There's a couple 27s in there. Okay. Um, Use the regression equation to find your predicted height based on your forearm length. Okay, so mine was y equals 0.911 is my slope times 27 plus 143 point, what was my equation? 479. Okay. Um, so I'm basically just take your equation wherever it is and replace the x or the forearm length with your forearm length. And if you put it in as a decimal, that's fine. So 27.5, we can put it as 27.5, okay, if you did decimal. Uh, and then we'll copy this over into decimals and see what we get. 168.53. 168.53 centimeters. All right. Um, Calculate your residual. So your residual is your actual height. So am I 168 centimeters tall? No. Um, we'll say that I'm 165. It's your actual height, so the number that you have in the survey, okay, minus the number you got from question 14. So I got 168.53. And in my case, that's going to be a negative 3.53 centimeters. Okay. Oh, three decimal places? Okay, shoot. Two. I need a two on there. So this will be a two. This will be a two. Okay. Whatever. It's fine. If you don't have three decimal places, that's fine. Um, Not worried about that. But if yours is negative though, make sure that you include the negative sign. Okay, that is important. So negative sign means that you're below the line, and we have some people are going to be below the line, some people are going to be above the line. Okay. Were you shorter or taller than predicted? So the line predicted I would be 168, but I'm actually 165. So shorter than predicted because, oh yeah, residual is negative. Right? I told you I'm a little shorter and I have monkey arms, right? So if your residual was positive, then you would say taller than predicted because my residual is positive, right? Easy enough. Okay. Use the regression equation to predict the arm length of Andre the Giant, who was 223 centimeters tall. Show your work, give 3 decimal places, include units. All right, so we're going to use our equation again. Where was my equation? My equation was up here. Here's my equation. But this time, I'm not going to put 223 in for my x because that is not an x value. 223 is their height, and that was my y in this case. So 223.5, and I'm going to find x. Okay. So to do that, I need to subtract 143 from both sides. So where's my calculator? 223.5. Let me see if I can shrink this so I can see on the same screen. There we go. All right. 223.5 minus 143.479. And that gives me 80.021. 80.021. Now that's not x. That is 0.911. That's my slope times my x. So I still have another step to do. I next need to divide both sides by my slope. So I'm going to do 80.021 divided by my slope, 0.91, and that's my x. Oh, I'm not showing my screen. Hold on. Did I lose my screen share for everybody? That's no good. All right. Let me know if you can see it. I just turned it off and turned it back on. Okay, yep, I got good now. All right. So what I did was I take Andre's height, 223.5, and I subtracted my y-intercept. If your y-intercept is different from mine, that's no big deal, okay? Then I need to divide both sides by my slope. And so I get, in my case, 87.839. 839 centimeters. That is my forearm, or that's his forearm length, okay? Or his predicted one, okay? By the way, if you don't know Andre the Giant, he was in Princess Bride, so you should definitely watch that movie. It's a great movie. It's good for kids. I think it's good for kids. Okay, fine. It's okay for kids. But it's great. It's a good. Oh yeah, and he was also a wrestler. I don't know him from that, but yeah, he was a wrestler as well. Yeah. He was defeated by Hulk Hogan. So, um, all right. Last question is, explain why the value for number 17 is outside the scope of our model. Okay, so 87 centimeters is his forearm length. Let's see, does anyone in the class have a forearm length close to that? No, I got like a 30. There's another 30 down here. Uh, or you could also look at their heights, like we've got a 187, but that's not close to 223. So I would come over here and I'd say none of the four arms measured was close to 87 or whatever number you got, uh, centimeters, right? Nobody was even close to that. That is outside the scope of our model. So that would be an outlier, and that would, make it so that our linear regression, we'd have to do some extrapolation, which is not accurate. Okay. But anyway, that's it for this project. So let's make sure that we share and change your access to anyone with the link. Copy our link, come over here to Canvas, and we will paste our link and submit it. Get our confetti. I got rockets this time, and we're good. Okay. All right. So if you have questions on that, that's okay. We'll talk about that in a little bit. I want to make sure that everybody, uh, gets, I want to make sure nobody's lost or anything. But for the moment, what I would like to do is I would like to jump to our sample midterm, which is on page 424. We're going to do 2 pages today, and then we'll call it a night. We'll work on the rest next time, okay? But I'm going to jump to page 424. Name. Following graph shows the 10 most popular casual gaming apps worldwide by revenue. What is the total revenue for these 10 games give units? So can somebody add these 10 numbers up for me? Our units here are going to be millions of dollars. Okay. Um, yeah, add those all up. While you're doing that, we'll move on here. What type of graph is shown above? Bar chart, Pareto chart, or histogram? What do you guys think? All right, I got some people with bar chart, some people with not bar chart. Uh, so it's a special type of bar chart. So um, a histogram is a special type of bar chart where your x-axis is quantitative data and your bars are all next to each other. It's not a histogram. We have qualitative data here because it's all words. Uh, a Pareto is a special type of bar chart where your tallest bar is first, and then the bars keep getting smaller and smaller as you go. So it is a Pareto chart. Now, do we have frequency or relative frequency? That depends on our heights. So if these numbers are percents or like decimals between 0 and 1, so the probabilities, those would be relative frequencies. These are not. These are in millions of dollars, so it is a frequency Pareto chart. Thank you, Gabby. So, actually, I don't, we got a different number this morning than that. So now I'm questioning. So we either got the wrong number. Okay, so Raya's got a different number. Nathan's got a different number. Oh my goodness. That's okay. We can answer this real quick. Um, plus 30.2 plus 37 plus 55.4 plus 0.2 plus 34.9 plus 34.3. And I got 565.1. Was that someone said that? Marion Raya, you got it. Now, I want to point out something though. So today is not test day. So uh, if you um, got a different number than me and you got the wrong answer, like don't freak out. That's okay. Today is not test day. So if you're like, oh, I got this number, and I want you guys to participate. I don't want to just do math in front of you. I want to teach you math. Okay. So I am not worried if you got a question wrong. And actually, even on the worksheets, I've graded, and on the exam, uh, I've given people full credit for a question, even if they got it wrong, if I can tell that they know what they're doing. Okay. So anyway, 565.1, that's the same number we got this morning. So we're gonna go with that. How many games made more than 50 million? Three, got four. Someone want to give me a tie breaking? Yeah, we'll go with four. So 50 million's right here, and this bar 55 is above 50, so we're gonna count all four of one, two, three, and gotta count that one too. Yep. And like I said, today's not test day. So if you get every question wrong today, that's fine. Actually, you learn more when you get a question wrong. So than if you get a question right. Okay. So yeah, shout those answers out. How much money was made by Gardenscapes or Homescapes? So Gardenscapes is 34.9, Homescapes 24.7. Now, in statistics, the word or we have to be careful about. Okay. Thank you, Rachel. 59.6. Uh, we need to be careful with the word or because if these numbers are related, if there's overlap, then we have to subtract the overlap. Okay. We'll talk more about that when we get to chapter 6, when we talk about mutually exclusive. Okay. Um, But for now, we don't need to worry about that because money that's spent on gardenscapes cannot also be spent on homescapes. Okay, so there's no overlap. Um, what percent of the total revenue from these 10 games was made by Royal Match? Royal Match was the biggest one, 17.3. I haven't actually played that. Is it good? And we divide by our total Royal Match. Yes, it is good. Okay, I'll have to give it a try. These are the most popular games of 2025, so it's not an old game yet. Um, 20, oops. So this will be 0.207, which as a decimal is going to be actually, I think we round this 7 up. I'm getting I'm getting 0.208, so 20.8%. Let me just check that real quick. It was 117.3 divided by 565.1, which is 0.207, but I'm going to round that 7 up because of the 5. Normal rounding rules apply. Okay. Um, Now, do you have to write all this out? No. If you just write the answer, I'm okay with that. Writing out the numbers helps me see if you know what you're doing. And I've said before, like if you just write the answer and you get the answer wrong, well, you're going to get marked off because I can't tell that you knew what you were doing. So, What is the shape of this distribution? Skew left, skew right, symmetric, or I don't know. Yeah, skew right, right. Does everyone agree? Any other answers? Yeah, there we go. I don't know what it is. It can't be determined. Oh man, you guys got it's a trick question. Uh, so our axis here is qualitative data. The axis here is in order from left to right, from highest down to lowest, because it is a Pareto chart. Every Pareto chart is going to look like it is skewed right. Okay. We could have put these games in alphabetical order, or we could put them in any order we wanted. Okay. Um, we can't talk about skew left, skew right unless we're looking at a histogram. A histogram has a quantitative axis here where you're looking at numbers. Okay. So, yeah. So again, like I said, we're here to work on these together. And like I said, if you get every question wrong today, that's okay. You learn from that. Okay. So if you're like, oh, skew right, skew right, skew right, and you're like, cannot be determined, like shout that answer out. Okay. Especially if you're right, then you can be like, ha ha, I knew it. So, all right. I'm going to stop the recording there. We're going to keep going with the next